Assalamualaikum and good afternoon. So today we will continue our discussion, but not in centrifugal pump anymore. So we are focusing on turbine. So turbine is a prime mover that converts fluid potential energy. Okay, in this topic we are focusing about water into kinetic energy and thus mechanical energy. So it means that we are now actually try to discuss about one device which is reverse from the pump. So pump is a device which give power to water, but turbine is a device that absorb energy from water. It is then converted to electricity by a generator connected directly to the turbine shaft. So the main purpose of turbine nowadays is actually to generate electricity. So this is a quite a common knowledge for you. So based on reaction and movement of water of the blade. Okay, wait a minute. I have a problem here. Okey, saya kita mula semula lah untuk tujuan recording. ada sikit Assalamualaikum warahmatullahi wabarakatuh. Today we will discuss about turbine. So turbine is a prime mover that converts fluid potential energy. So means that potential energy here means that fluid must be at the higher level. So into kinetic energy and thus mechanical energy. It is then converted to electricity by a generator connected directly to the turbine shaft. So normally turbine is used to generate electricity. So based on the reaction of movement of water to the blade, the turbine can be divided into two main types. So please take attention to this word, based on the reaction of movement of water. So this is the main characteristic. So means that based on how water enters the turbine, so we could divide turbine into two types. One is reaction turbine, and one of them is called Francis turbine. So Francis turbine here is actually one type of reaction turbine. So it requires low flow and high flow rates. So and then another type of turbine is impulse turbine. So and then one example of impulse turbine is called Pelton wheel. So it requires a high volume and a small quantity of water. So we will learn these two turbine, okay? So and then, but now in the first half, we will focus on Francis turbine. So what is actually the simple word for reaction turbine and impulse turbine? Okay, as I said here, the way water comes into the comes on the blade is actually the turning point of us to classify the turbine. Okay, for Francis turbine, okay, the idea is the work, the mechanism is actually same with the centrifugal pump. So means that the water will enter the blade, and then the kinetic energy will transfer to the blade, and then the water will flow out. Okay, so the idea is 100% like Pelton wheel, like impulse turbine. Okay, so means that if you have turbine here, all the blade here will be submerged into water, or water will make contact to all the blades for reaction turbine. Okay. However, the impulse turbine, for impulse turbine, the Pelton wheel is something like this. So we have a wheel, so and then at the end of each wheel, we have a stopper like this. So it is equal to windmill. So there is simple, another example of impulse turbine is the windmill. Or kita kata kincir air, water mill. Okay, means that, okay, for example, if you have a water mill, so you are place your water mill here under the waterfall. So water will fall like this, falling like this, and only certain region of water or certain region of wheel that make contact to water like this. So mean area at this one is actually not make contact with water. So only certain area of the wheel make contact with water, and this water will push the blade and it will rotate the wheel. So that's called the impulse movement. So means they are hit and run. Actually, that is the simple idea of impulse turbine. So we will discuss this when we enter the Pelton wheel chapter. So it is because it is easier for you to understand because you already know about the Francis turbine, and I will explain about the Pelton wheel later on. Okay, so this is the introduction for the Francis turbine. So and then I will go this very fast, a little bit faster, so you could read this from my slide here. You could pause it and then you could read it. So it is actually invented by one engineer named James B. Francis. Okay, so James B. Francis. So he proposed the reverse mechanism of centrifugal pump. So this is the simple story of this. And then he called that turbine as Francis turbine. Okay, so what is the component and how Francis turbines works? So it's very simple. So Francis turbine still have a component like centrifugal pump. It will have volute. So it will have a vein, a guide vein here. So the guide vein is not exist for centrifugal pump. So however, for Francis turbine, we need to add a guide vein here. So and then we have a runner. So in centrifugal pump, we call runner as impeller. So I will discuss about that. And finally, it has draft tube. Okay. So and then, okay. So this is the basic diagram for Francis turbine. So the idea is we have an inlet here. So the inlet is designed to meet blade. So and then the inlet here will have some special design like this one. So we call this design is a volute. Okay. So and then this volute, okay, will push water to enter every section here to enter the blade. Okay, to make contact to the blade. So and then when water hit the blade, when water flow through the blade, so the blade will rotate. Okay, and then the rotation of blade here, okay, if you could see here, so if water comes in here, okay, let's say here, so the water comes in here, so it will rotate the blade. So and then if it's rotate the blade here, so the blade is attached with a shaft here, so this shaft will rotate the generator. So when the generator is rotated, so it could produce electricity. So this is the mechanism, the basic mechanism of turbine. Okay, so what is guide vane? So guide vane is actually, as you know, so the water is come from the higher place. So everybody knows that if you want to install a turbine, you must install from attached with water that flow from the higher level, because we want to absorb the potential energy that have in water into the blade. So you must put your water at the higher place to give more potential energy. So and then when the water flows down like this one, so you know for sure it will flow in turbulent condition. So turbulent means the direction of flow is actually unpredictable. It is not laminar. Yes, it is falling down. You could see roughly it is falling down vertically, but actually, so it's maybe in too many direction. The flow is actually turbulent. So the turbulent flow is actually will create will 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 not give a good efficiency for turbine. So what engineers do, engineers will put one stationary blade like this. Okay, the vane here mean blade. Okay, so we put a stationary vane like that because we hope that water that flowing down at any direction will first hit the guide vane, and then when it's hit the guide vane, so it will flow at one specific direction. So it means it's something like a vane, a blade that could channel the water flow very well. So the angle of guide vane is very important because it will influence the efficiency of the blade, the efficiency of the turbine. Okay, I hope you could understand here. So we have water from higher place comes into the volute. So and then he enter the guide vane, and then the guide vane will guide the water very well, and then the water will hit the blade here. So when the water hit the blade, you know that water has velocity, and that velocity will push the blade to rotate. At the same time, when water go through uh, blades, okay, the kinetic energy from the water is being transferred to the blade. So the water, the potential energy from the water, the potential and also the kinetic energy of the water is being transferred to the blade. So and then this energy will rotate the blade, and then it will rotate the shaft, and then it will rotate the generator, then you could get the electricity. Okay, after After he flow through the blade, so what happened? The water will flow to the center of this volute, center of this device, which is called the draft tube. So this is the draft tube. So mean all the water from all the direction here will flow to the center, and then it will goes out through the draft tube here. So means that in centrifugal pump, okay, I will compare with centrifugal pump. So in centrifugal pump, water will flow from the center point. We call it an eye. So and then water will rotate the blade, and then water will comes out into the volute outlet here. So that is the centrifugal pump. So for Francis turbine, so the mechanism is 100% reverse. So means that water from the higher level comes into the volute like this, and then he go into the blade. So water will rotate the blades, and then this rotation will create electricity, and then the water will go to the center of the uh, blade here. So and then it will flow out as a draft tube. Okay, that is the mechanism between centrifugal pump and the Francis turbine. Okay, so again, we will evaluate about the volute. So the volute here is the same. Normally for inlet, so we have the uh, bigger cross-sectional area because we want to have the slow velocity, and the pressure is high, and then when it's entered this one, okay, it's become the cross-sectional area is quite small. Okay, it's become smaller and smaller because it want to increase the velocity. Why we want to increase the velocity? Because we want to make sure that it has more power, more energy to convert to to be extract by the blade. So and then you have a high velocity here, so means that it could rotate the blades high in high velocity too. So and then after that it will go out through the draft tube. So normally for draft tube, so we will draw something like this because we want to make sure that water could flow easily for the outlet. Because at this region, uh, if the water cannot flow, so it will disturb the flow inside the volute. So mean the disturbance, or if the water gets stuck at the outlet here, so means that the velocity at the inlet here, at the volute here, will become slower. That's why we don't want that happen. So that's why we design our draft tube here is expand channel like this, because we want to make sure that all the fluid here will flowing down by gravitational and by gravitational force easily. So means that there are no traffic jam for that water. So it is to make sure that the high momentum that already have in this situation is not being disturbed. Okay, this is for volute and Guidevane. So and then if you go for the runner here, so the runner is actually the same things with blade, with impeller. Previously in centrifugal pump, we understand that if we talk about one piece of blade here, so we call it as a blade. But if this blade is attached on a system like this, okay, we have another blade here. So and then we have another blade here. So the set of this one is called the impeller. So this is for centrifugal pump. Centrifugal pump. Okay. So same goes with the Francis turbine. Okay. So for Francis turbine, Okay, so we have a blade here. So this is blade. All okay. The single one is blade. Okay, let's say we have a blade here. Okay, and then this blade is actually attached with on a disc like this. Okay, so it attached with a disc like this, and the whole thing here is called runner. That's all. This is actually the one system of one system one parts of turbine, which consists of a lot of blades. Okay, that's we call runner. And then the draft tube here, as I explained just now, it is actually the outlet of the water. So we design it this way because we want to make sure that the water will flow out easily. Okay, this is some example of Francis turbine. So you may see this example in your textbooks. Okay, I hope you could read about centrifugal pump, Francis turbine, and also Pelton wheel from the textbook. I also upload the PDF of the textbooks on my website, so I hope you could look into it. Okay, again, so for Francis turbine, it is important for us to draw the velocity triangle. However, because the mechanism of Francis turbine is actually the reverse direction, the reverse mechanism of centrifugal pump, so I think you could draw velocity triangle for Francis turbine easily. So the idea is the same. So this is the velocity triangle that given in your textbooks. Okay, so they are using a slightly different terms. So, but I will show you how to draw the velocity triangle for Francis turbine according to our syllabus. Okay, so this is actually uh, another example for reaction turbine. So it is called the Kaplan turbine. So this is not our syllabus, but why I show you this one, because Kaplan turbine is actually the reverse mechanism for the axial pump. So previously we learned about the pump. We have an axial pump and we have a centrifugal pump. So similarly with the turbine, we have Francis turbine, which is the reverse mechanism of centrifugal pump, and we have a Kaplan turbine, which is the reverse mechanism for axial turbine. So this is for your information. So I hope you could read this. Okay, this is the velocity triangle. So I hope you could give more attention here. Okay, so for Francis turbine, normally people will use for water. It is not necessary to use Francis turbine for air because it is not easy to have a windfall or something like that to be installed for Francis turbine. If you want to absorb energy from wind, normally you will use an axial turbine. So one of the idea of axial turbine is actually the wind turbine. That's why if you see that in offshore, they have a big fan like that. So this is actually the idea of wind turbine. But the inlet direction and the outlet direction is still at the same direction. So we could classify this as the reverse mechanism of axial pump, which is actually some kind of turbine that have same idea with the Kaplan turbine. Okay, but we are not analyze about this one. We are focusing on Francis turbine because normally in water dam, in electricity dam, and so on, we will use Francis turbine to generate electricity. Okay, that's why in Francis turbine, there are no type of blade. In centrifugal pump, we have three type of blade. We have backward, forward, and radial. But in Francis turbine, normally people will use a backward blade. Okay, so this is the blade and this is backward. Okay, but you must know that you need to draw the velocity triangle for Francis turbine in reverse direction of centrifugal pump. So normally we will draw centrifugal pump like this, and then we draw the rotational speed from the right to the left. But for drawing Francis turbine velocity triangle, you need to draw the blade like this, which is the reverse shape from this one. And then you need to draw the rotational speed omega is reverse like this one. Okay. So this is the first thing that you should to know, that you should know. So the idea is you are reversing the centrifugal pump. Okay, this is the blade. So, and then this is the rotational speed. Okay, as I said, there are no type of blade because usually engineer will use this type of blade. Why? Because water will fall and goes in like this. Okay, to make sure that this water will be catch properly by the blade. So it is good if we could create blade that curve like this. I think you could imagine that one. We want to absorb energy. Okay, if we have blade like this one, so mean water could go a good flow like this. So mean it will reduce the capability of this blade to absorb all the energy from the water, because the water is actually could slightly uh, go to another direction. Okay, you could shift it easily. So this is not the correct design or a good design to absorb energy. So what engineers do is, as you could see here, so if you could see here, so the design is a little bit like this to make sure that it could catch the water flow, and then it could absorb as many as they can the energy from the water. Okay, this is the idea why in Francis turbine we don't have three type of blades. Also, it is different with the centrifugal pump. Okay, but the mechanism is reversed. You could see it. Okay, first, so the idea is the same. You need to draw the actual velocity. So the actual velocity at inlet is here. So if you see, so the location of the inlet here is same, okay, with a centrifugal pump, but the direction is reverse. Okay, and then the reverse, the another thing is for centrifugal pump, okay, this point is outlet, but for Francis turbine, this point will become inlet because the water start to enter at this point. And this point is actually the outlet, because at this point, the water will go out into the eye here. Okay, so this is the actual water flow. And then, again, the actual water flow out in this direction. So I could make it shortcut. So nowadays, engineers success to design a good blade design, make the velocity of whirl at outlet here is equal to 0. So means that there are no more turbulent at the outlet. So the calculation of the theoretical head, the Euler head, will become maximum. Okay, I will show you about the Euler head later on. So please focus this one. So this is the actual velocity at outlet. So and then we could have component velocity. So we have component velocity relative to the blade angle. So this is the VR1, and this is the component velocity relative to the runner speed. So and then we could at the outlet here, so this is the component velocity for the blade angle, and this is the component velocity for the runner rotation, runner's rotation speed. Okay, so and then again, because this uh, triangle cannot use trigonometry, so we try to make another triangle. So one is the component which reflect the theoretical velocity, which is VF1, and this is the VWOL1. So and then at outlet here, because there are no more turbulence, so mean the VWOL2 is equal to 0. So we could assume that V2 here is equal to VF2. Okay, so and then, so about the angle. So again, it will have an angle, but it is, I think you already know. So this angle is actually will reflect the angle of blade. So for example, if you have this one, so you will have, okay, some people so you have this one. Okay, this is the angle of blade. Okay, so means that I hope you could understand the angle from the question. So at outlet here, so normally it will stated as this one, and or it state the angle of here, and it is equal to the angle at this area. So and then about the diameter or the radius. Okay, this is quite confusing for student, because we assume that this is the inlet. Okay, some question they will call this is as the inner. This is the outlet. Sometimes they call it as outer. Because sometimes in certain textbook, they will say, oh, inner diameter is 40 centimeters and outer diameter is 20 centimeters. So students start to confuse why outer diameter is smaller compared to the inner diameter. So it is because they are referring the inlet and the outlet. Okay, please be careful about this term. Because normally when we have a pipe like this one, okay, for sure pipe has thickness. So people will say that this is the inner diameter and this is the outer diameter. So mean for sure outer diameter is bigger compared to inner diameter. So but if we are talking about turbine, so maybe it's reverse. So it's contradict, because the location of inlet and outlet is like this. So please be careful and please understand the velocity triangle and the location of the velocity triangle. Okay, so this is the enlarged velocity triangle. I hope you could draw like this. So this is point 1 or inlet point. So and then this is the outlet point. So, and then after the water flow at point number 2 here, so the water will flow into the center point here, which is the draft tube. So in centrifugal pump, this is an eye, the starting point of the water flow inside a pump, but in Francis turbine, the water will end its flow at the center here. So it will go out through the draft tube. And then basic equation. So again, so we have these two basic equation. So the first one is U is equal pi dn over 60, and the VF is equal Q over K pi dB. So the usage of these two equations is actually the same like the centrifugal pump. So I will not explain it again here. So you could use that the same way that you use in centrifugal pump. So this is the precaution that you must know, that in Francis turbine, inlet diameter is larger compared to outlet diameter. It is as I showed previously, so the location of inlet and outlet. So I hope you could understand this statement. Okay, so and then this is the Euler head for Francis turbine. So again, Euler head is actually the the theoretical head that can be produced by a turbine. And for sure, turbine has certain type of losses, and then the output, the output of turbine may be a little bit smaller compared to theoretical. So later on, we will discuss about the efficiency. Okay, first we go for the theoretical. So the Euler head of the Francis turbine can be written like this one. So I'm not showing you the derivation. Okay, so the derivation is actually as same as the derivation of Euler head for centrifugal pump. But okay, this is the main point that you should understand. Okay, for pump, so let's say we are going for pump here. For pump, water comes from the center point. So water is actually have water. Okay, so water comes from the center point, and then water will go through the blade, and then the transfer, the energy transfer is from the pump, means from the blade here to water. So means that water at point number 2 will have more energy compared to the water at point number 1. That's why in centrifugal pump, the Euler head is point number 2 minus point number 1. Okay, I hope you could get it. So you please refer to the notes of centrifugal pump. Okay, but in Francis turbine, the sequence is changed. So you will find that it is U1 V-well 1 minus U2 V-well 2. So it's reverse. So it's changed. So why it's changed? So the explanation is actually the same. So we have blade here, and then water comes from the higher place. So will flow on the blade and then will go out. So this is point number 1 and this is point number 2. So because turbine is actually a device which absorb water, absorb energy, so means that at point number 1 here, water has more energy because it comes from higher level. So it has a lot of potential energy which is converted into kinetic energy. So when it flow on the blade here, so the energy from the water being transferred to the blade. So now at point number 2 here, the energy inside the water is lower compared to the energy at point number 1 here. That's why we do the calculation. We deduct the value of 1 with the value of point number 2, because the nature is the energy at point number 1 is larger, is greater compared to the energy at point number 2. So if you want to prove the Euler head for Francis turbine, okay, please look at derivation for Euler head for centrifugal pump, and then you just reverse the sequence. You just reverse the location of point 1 and point 2. You just make sure that you put point 1 minus point 2. Then the explanation, the calculation will be the same. So and then if the design is very well, the V-well 2 here will equal to 0. So means that we could neglect with all these equation. So the Euler head for Francis turbine can be calculated using this equation. So and then the work done by the runner. Okay, you could calculate it as rho GQHE. So, and then you could substitute the equation for Euler head. So then you will have this one.